Hey everyone, and welcome to The Explainer. Today, we are focusing entirely on one absolutely mind-bending paradigm shift, the Pgx Os. We're not just talking about a simple update to how we write code here. No, we're talking about a fundamental reimagining of how source code even exists in the first place. So if you deal with intellectual property, software security, or honestly, if you just love bleeding-edge computer science, you are definitely in for a treat today.
Let me start by asking you something that, well, it might make some of you a little uncomfortable. Are our source code repositories fundamentally broken? I mean, really think about it. Our most valuable intellectual property, the literal DNA of our software, usually just sits there in repositories or on developer machines as plain, highly readable text. Even if it's tucked away behind a firewall, once you're in, the code is just sitting there completely exposed. In an era where advanced data scraping is the norm, is that a massive vulnerability? You bet it is. Okay, let's dive into this contrast right away, because this is exactly where things get wild. In the classic view, as we all know, a software project is essentially just a folder full of text files. You open them, you read them, you edit them. Simple, right? But Pgx Os introduces an unimaginable alternative. It treats code as a DNA-bound biological entity. In the Pgx view, a project is actually a sealed organism. It possesses a genotype, a locked genetic structure, that only turns into a phenotype, meaning readable code, under strictly authorized conditions. So here's our agenda for today. We're going to cover 1. The source code problem. 2. The Pgx Os revolution. 3. Team roles. 4. Step 1. The repository. 5. Step 2. The reanimation. And finally 6. Step 3. Sealing and release. All right, let's kick things off with Section 1, the source code problem. The core problem is that code resting as readable files is constantly at risk. And in the AI era, it's a glaring issue. We literally have AI crawlers scraping cloud repositories non-stop. We've got bots silently reading code just to train unauthorized models. And even internally, if a developer's machine happens to be compromised, well, the plain text source code is just sitting there on the hard drive, totally ready to be copied. The vulnerability isn't just about network access, it's the very state the code rests in. Which brings us to Section 2, the Pgx Os revolution. Enter the Pgx container, which stands for Project Genome Execution. Now, what makes this system so entirely unimaginable is that it was engineered entirely by a single developer, Ralph Krummel. Why? To solve massive vulnerabilities that huge corporations simply couldn't fix. And because this architecture is so incredibly disruptive to standard security models, virtually no public information exists about it. The code literally does not exist as readable files when it's at rest. It's a sealed project body. It isn't just an encrypted zip file, it is a locked biological structure that only materializes or reanimates into a temporary readable workspace when incredibly strict, multi-layered conditions are met. Let's break down the anatomy of this container. First, it has a manifest, which acts as a sort of reanimation contract. Then it has a file graph that dictates its canonical structure. But here is the truly fascinating part, the sub-QG field. Pgx creates a morphodynamic field representation of the code, using a KO1 to KO5 operator family. Think of this as the project's unique mathematical DNA. Add to that standard cryptographic HMAC and SHA-256 hardening, and you basically have a software organism that absolutely refuses to exist unless every single piece of its identity is perfectly validated. Moving on to Section 3, Team Roles in Pgx. So a Pgx team workflow relies on 3 main roles. First, you have the project owner. They manage the project DNA and create the initial Pgx containers. Then you have the developer. Now, the developer doesn't just clone a repo like they normally would. They actually reanimate the workspace locally, make their edits, and then seal it back up. Finally, there's the reviewer. The reviewer doesn't just look at text diffs. They're actually checking the secure audit logs and lineage to accept the newly sealed Pgx container into the main vault. It's a totally different ballgame. Let's move to Section 4 and see how this builds step by step, starting with Step 1, the repository. This brilliantly illustrates the shift we're talking about. In a classic Git setup, your repository is totally full of open source folders. Anyone with access can just browse the text. But in the Pgx workflow, your GitHub or GitLab is entirely empty of readable code. It essentially becomes a simple blob store that only holds encrypted .pgx containers. The repository is no longer a library of code, it's simply a secure transport vault moving sealed biological blobs between team members. Next up is Section 5. Step 2, the reanimation.
Now, what's really interesting here is the actual Pgx Os desktop interface. This isn't theoretical, guys. This is a real working tool. To bring the code to life locally, the developer absolutely must input the correct project name, provide their specific device profile, which by the way means this code won't open on a stolen laptop, and finally, they have to input the unique project DNA. As you can see, the DNA string is something like Ralph Alpha 2026.
When you hit Session Open, a very rigid sequence kicks off. First, it validates the DNA and the device profile. Second, it checks the cryptographic HMAC and the sub-Q field integrity that we talked about earlier. If and literally only if all of this is a perfect match, it materializes the code. It physically generates the files into a temporary ephemeral workspace on your machine, which then allows you to open it in your standard IDE like VS Code. But if the DNA is wrong or the device is wrong, it doesn't just block access. The code body simply refuses to form in the first place.
Which brings us to Section 6, Step 3, Sealing and Release.
Once you're done coding, you don't just push open text back to a server. You seal the session. The code gets packed into a brand new PGX container with an updated lineage. And here is the absolute genius part. That ephemeral workspace we just talked about, it is completely destroyed. The readable code vanishes from your local machine like it was never there. You're just left with a new, sealed PGX genome, which you then send back to the repository for the reviewer to check.
So the crucial point is summarized perfectly by this core principle from the source architecture itself. Pgx zerstört Code nicht. Pgx verhindert, dass Code ohne gültige DNA überhaupt als ausführbar Körper entsteht. Translated, that means Pgx doesn't destroy code. Pgx prevents the code body from existing at all without valid DNA. It is a profound shift from trying to hide existing files behind firewalls to engineering a reality where the files simply do not exist in the physical world without the proper authorization keys.
I want to leave you with this final provocative thought. Take a hard look at your current workflow. If your team's most valuable asset, your source code, isn't stored as a living, sealed entity, just how safe is your intellectual property today? Pgx Os challenges literally everything we take for granted about file storage, turning code into a sovereign, DNA-bound organism. It's an absolutely fascinating leap forward in software security. Thank you so much for joining me on The Explainer today, and keep questioning how we build the future.